Elegant in design, precise in function, built with one purpose: to end lives. The machinery of execution stole from and inspired many of the world's greatest inventions. It mechanized torment and terror. Coming up next, the engineering behind the machines of malice. Without a doubt, technology has pushed society forward. But along the way, the invention of torturous machines has made executions easier and incredibly cruel. And there is no time period with a worse reputation than the Middle Ages, when punishment went high-tech. The world's most bizarre and sickly designed machines sprung from this era's notorious torture chambers. On the surface, it seems like death was engineered to be as painful and as gruesome as possible.
Even the church who implemented, and some of the popes who implemented some of these inquisitions, were not prepared for how the public was going to embrace it and implement it.
The Inquisitions were church-approved campaigns to root out anyone who deviated from the official doctrine.
This tool of the church was like the genie coming out of the bottle. Impossible to put the genie back in, impossible to stop the momentum.
And there is no machine of torture reviled more by its victims than the rack. The rack exploits the physics of torque to stretch and ultimately dismantle the human body. For nearly 600 years, heretics, traitors, and common criminals all endure unfathomable pain on the rack. In its most simple form, the rack is a solid wooden table with axles to pull human arms and legs in opposite directions. Tension gradually increases, stretching muscles to their tearing points and ultimately pulling joints from sockets.
It only took 2 people to actually accuse you of a crime. So everybody and anybody could fall victim to this. The rack was one of the most common devices that people could find themselves up against.
The first order of the torture would just be pulling the joints from their sockets, and then it would actually tear the ligaments. You would be crippled for life.
But what makes the rack so insidious is its precision. An operator can stretch out a torture session for days.
The way the machine works is you're going to take a lever arm, which was simulated with these pipes. I'm going to demonstrate with the small one. We're going to apply a force which creates a torque. That torque, the actual energy, is going to get transferred through the ropes to tension the ropes and stretch the actual person.
The physical principle of torque creates the destructive power of the rack. Torque is a measurement of the force needed to rotate an object. So pushing on the lever arm creates a torque on the axle, which in turn tightens the rope.
And now as the rope tightens up, it's going to get a little bit harder for me to push down because I have a very small lever arm. And you can see I'm getting to the point now where I'm actually using a lot of force. So I'm going to go to twice the size of the actual lever arm and try this one again. Go back with one arm and push down. Now, as if I was the executioner, I could put an immense amount of force and tension on the person that I'm trying to pull apart.
As the executioner continues to apply a force and increase the tension, the arms, which are lifted above the victim's head like this, would continue to pull. This would just slip right out without much force. Once the shoulder is popped or dislocated out of its socket, the pain continues because the nerves and the muscles are all being put on stretch in an abnormal position.
The point of drawing out a session on the rack is to extract confessions, or to purify through pain. The rack gives interrogators complete mechanized control over the victim's pain level. But just how much force or tension goes through the rope as the rack axle turns? A dynamometer measures the tension created by heavy loads. It will measure the forces slowly stretching a person apart on the rack.
Making sure that the dynamometer is actually zeroed. Okay, now we're good.
Okay. Start moving?
Yep, you're in locked position. Okay, so now we're reading 75 stable. So that means there's 75 pounds trying to stretch you at this time. Okay, let's go ahead and go one click. Right there. Okay. It's another click. And now we're at about 120 pounds. So each one of these clicks is worth about 40 pounds of pressure, putting tension onto the rope, stretching the person on the rack.
When inquisitors pull the lever of the axle, they apply more tension on the rope.
See, you're already up at 260, you're 300.
This is much more tension than a torturer can generate pulling on the rope by hand.
And I barely moved this lever arm and it jumped up to 300.
But you're holding 225 pounds right now.
But how does it look when a person is strapped to the rack? This anthropomorphic dummy will endure what no human would ever want to experience, a complete racking.
It's getting tough.
Yeah, it's getting harder. Still not that hard though. There's only so much tensile strength you can apply to a joint before it's going to give, which is why you can get a dislocated shoulder. In this particular case, your shoulders will probably be the point that's going to give first.
As opposed to the shoulder joint, the hip joint and the knee joint and the ankle joint are probably less likely to dislocate. The main reason for this is, one, they have larger muscles that are covering the joints, so they have more protection. And the other is that as we come down to the knee here, again, we're pulling in line with the normal axis, so it's quite difficult to dislocate, whereas the upper extremity of the shoulder is being pulled 180 degrees.
With this lever arm system, this gave the executioner a great way of being able to torture his victim. He could increase the load to put significant pain upon him, and then he could actually release the load at the same time, letting him breathe, letting him be able to catch his breath.
The precision and power of the rack is exactly what makes it one of history's most prevalent punishment machines.
Because the rack was easy to use and very precise in its nature, it found its way to countries throughout Europe. Each country would create its own modifications based on who and what and how it needed to be used.
This Italian version comes equipped with an additional torture feature.
As you were pulled down, and you'd find yourself going over these spikes, slowly turning, going along your whole back section.
During the Spanish Inquisition, interrogators operating on behalf of the monarchy turned the rack design on end. This vertical position makes it easier to question the accused and beat them while fully extended.
The Spanish rack during the Inquisition was a tool of severe pain. Your arms were not put up like this. No, they were put up behind your back, elongated, and then you were slowly brought back down. And we know this based on the illustrations that have been left. These illustrations not only show how the device was used, but also some of the other things that might take place while people were on the rack. This could include burning, piercing, puncturing. This rack was state-of-the-art, using this cog mechanism to lock in pressure with each turn. It required very little strength, and it could be operated by one person.
The physical principle of torque is the backbone of many modern machines. Automated gears are high-tech versions of stick levers and axles. They create torque power in everything from electric drills to car transmissions. In their quest to engineer the most fearsome, painful, and reviled machines, inquisitors and executioners of the Middle Ages focused their inhumane creativity on specific body parts. The intent is to deliver localized torture, not to kill, and it's a pint-sized machine that takes the biggest bite. The small and seemingly innocuous thumb biter originates in 14th century Scotland. These devices have almost childlike names, like Pennywinkies or Pliny-winks, but the damage they cause is far from innocent.
The idea was to crush the fingers between these pieces of metal. And if you can imagine slamming your finger in the door and what that might feel like, this is not so different, except that here you have constant pressure and pain.
You're going to put your thumb in here, or fingers, You're going to put the top plate down. Now you're